So in this video, we're going to talk about quadratic equations in factored form. And here's a couple examples with, and again, this is something we should be aware of because we spent some time factoring quadratics earlier in this class. And of course, when we were factoring, they didn't have little y equals. It was just like this. So we know how to put things in factored form. But if you have something in factored form, if you have a quadratic in factored form, and you're trying to graph it, the cool thing is that we know that because of the zero products rule, that if you set this equal to 0, it's really easy to solve it, right? We know that this would mean that x plus 2 is equal to 0, or x minus 4 is equal to 0, and x equals negative 2, x equals 4. Now, why is that significant? Because if you take a function and set it equal to 0, that means you're finding when y is 0. And when y is 0 on a graph, that means that you're sitting on the x-axis, right? So this is telling me that when I plug in negative 2, I get out 0, and when I plug in 4, I get out 0. So that means that the graph hits this point right here, and then 1, 2, 3, 4. That point right there. Okay. So so that gives us some information about the graph. And remember, we've said in the last video that when you're trying to graph quadratics, one of the most important things you need to know is the vertex. So we're coming up with each form. We're trying to figure out a way to find the vertex and then graph the rest of the function, of course. So in this case, we know, because a quadratic is symmetrical, that the vertex has to be exactly half in between these 2 points, because all parabolas are symmetrical, and if we have 2 points that are level with each other, we know that they're reflections of each other across the line of symmetry of the parabola. So because this one crosses, or this point is at negative 2 and that point's at 4, that means we can go halfway in between them, and we know that this line right here is the line of symmetry of the parabola, which means the vertex has to be on that line somewhere. So we know the vertex is located at 1 comma something, okay, because it's on this line somewhere. It's somewhere on the line of symmetry. And of course, if we have an x coordinate, we can always find the y coordinate, because this is just the input, and we get the y coordinate from the output. So all I need to do is find out f of 1, which means I'm plugging 1 in here. So the vertex is located at 1, comma, if I plug a 1 in there, that would be 3. Plug a 1 in here, that would be negative 3. And so that would be negative 9. So we know that this parabola has a vertex at 1, negative 9. So that'd be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means that we would have a parabola that looks something like this. So again, just by grabbing the two x-intercepts, in fact, you can see the x-intercepts there, right? It's x plus 2, we know that negative 2 is what makes that little factor equal to 0, and 4 makes that factor equal to 0. So when it's in factored form, it's really easy to grab the x-intercepts, and then we know the vertex halfway in between those x-intercepts, and then we can just plug that x value into the original equation to find out the y value. Okay, so let's do the same thing with this over here. So we know that if we were to set this equal to 0, that would mean that x is equal to 0, or x plus 3 is equal to 0. And again, why are we setting equal to 0? Because we're trying to find the x-intercepts. And when you're on the x-axis, we know the y value is equal to 0. Right? So that's why we set the function equal to 0. So this tells me that the x-intercept is going to be at 0, 0, 0, right? And at this one would be x equals negative 3, wouldn't it? 1, 2, 3. Sorry, my line's kind of bumpy there. So then we know that the vertex has to be located at halfway in between those 2 points. So halfway between those 2 points would be negative 1.5. That's halfway between 0 and -3. And then, of course, the y value would just be the function evaluated at 1.5. So then we go back up here and say, okay, f of -1.5, that would be equal to -1.5 times x, times -1.5 plus 3. And of course, that would be -1.5 times 1.5, which would be -2.25. So I'd go over here, and again, so the vertex is on this line somewhere because it's halfway in between the 2 points. And I go down to -2.25, so it'd be right about there somewhere. And something like that. So again, I'm able to graph this without much trouble by finding the x-intercepts and then just finding halfway in between them. Okay, so that's graphing from vertex form. I'm sorry, from factored form. Okay, and the next video I'll make, this is a short one. The next video I'm going to make is graphing from standard form, and then I'll make a video on how to switch back and forth between the different forms. And that one will be, of course, very exciting. So you can look forward to that. All right, signing off for now.